5.3 is vector product or cross product. So we'll be using the cross symbol. And to do that, we need to use our right hand only, where the thumb of your right hand will show the direction of the cross product. So let's look at the first picture right here. Ignore the image of the hand. So as you can see, this is the origin O and this is the coordinate A. Therefore, this is the vector OA, or let's call that vector A. And since this is the coordinate B, therefore this is the vector OB, or we can call it as vector B. So say that I want to do A cross vector B. So we're gonna put our hand where your thumb is at the origin, and you're gonna straighten your fingers towards your first vector, which is A. And then what you're gonna do is you're gonna curl your fingers like this. You're gonna curl it towards the second vector, which is B in this case. So as you can see, since when you do this vector product, you can see that our thumb point upward. Therefore, this will be the direction of our vector product, which is A cross B. For the second picture right here, this is the origin, so you're gonna put your thumb at this position. And this one right here is vector OA. Let's call that vector A. And this one is vector OB, or vector B. So let's say I want to do vector B cross with vector A. So we need to put our straightened fingers towards the first vector, which is B. And then you're going to try and curl your finger towards the second vector, which is A. So as you can see here, when you do that, your thumb will point downward. And that's the direction of the vector product, which is B cross A. If you're struggling to do this, where you need to use your right hand, you can also try and use the letter D and the letter P. So if you try and draw the letter D, look at the direction of your drawing. First is it goes anti-clockwise rotation, and then it goes upward. This means that when you do the vector product and it goes anti-clockwise, this means that the direction of your vector product is upward. Next is if you use the letter P, the drawing of the letter P. So when the rotation is clockwise rotation, you can see that it goes downward. So this means that when it is clockwise rotation, the direction of your vector product is downward. Say that we have two vectors, vector A and vector B. So if we have theta, where theta is the angle between the two vectors A and B, where both vectors must go outward like this, and therefore the angle between the two vectors is theta. So if we are given the value of theta, we need to use this formula. A cross B is equal to magnitude A times magnitude B times sine theta times with unit vector U, where the vector U is A cross B. Therefore, the unit vector U is the cross product, which is A cross B, divided by its magnitude, which is the magnitude of A cross B. Now, what if theta is not given? Therefore, we need to use the concept of determinant. So you're gonna draw determinant for 3 by 3. In the first row, you're gonna write I, J, and K, the unit vector I, J, and K. For the second row, you're gonna write down the first vector, which is A. And for the last row, you're gonna write down the second vector, which is B. Next, you need to put the plus sign at I, minus sign at j, and plus sign at k. In the next row, we're gonna do 3 determinant. The first determinant is for I, the second determinant is for j, and the third determinant is for k. So note that for I, the sign is positive. For j, the sign is negative. And for k, the sign is positive again, like this. And next, we need to fill in inside the determinant for each I, j, and k. So I is here, so you're gonna close the first row and the first column. So you're gonna take the rest of it and put it inside the determinant for I. Next, for j, j is here, so you're gonna close the first row and the second column. So you're gonna write down the rest of it in the determinant for j. And the last one is for k. So since k is here, we're gonna close the first row and the third column. So we're gonna write the rest of it into the determinant for k. And now we're just gonna do the calculation for determinant for each I, j, and k. So just follow. For I is positive, so for I is positive. For j it's negative, so we're gonna have negative. And for k it's positive. So let's do the first calculation inside the bracket for I right here. So the determinant of 2 by 2 is a2b3 minus with a3b2. Next, for the second determinant, it is a1b3 minus a3b1. And lastly, for k, this is supposed to be b2. So it is a1b2 minus a2b1. And lastly, you're gonna simplify everything so that the final answer is left in this form. Something I plus something j plus something k. So as you can see, by using vector product, the answer should always be a vector. Since for the second method, you can clearly see that we have I, j, and k. The same goes for the first method, where A cross B is magnitude A times magnitude B times sine theta. So you know that these three will just give us a constant. But for the unit vector u, since it is a vector A cross B divided by its magnitude, so the magnitude is just a constant, like the first three here. But we do have the A cross B in the numerator. So in the end, the right hand side will just be a constant times with A cross B. So this means that this is still a vector as well. So to summarize, vector product will give you a final answer of a vector